Assalamu alaikum, my dear viewers. Have you ever wondered how we obtain detailed images of our planet from space? Welcome to the captivating world of remote sensing, a scientific marvel that allows us to view Earth like never before. It's a tool that transcends borders and barriers, offering invaluable insights in various fields from meteorology to geology, from geography to environmental science. It's like having a bird's eye view, but a bird that's soaring thousands of miles above. The key to unlocking these cosmic snapshots lies in the fascinating process of image interpretation. Image interpretation is not just about looking at a picture, it's a science in itself. It's an art of understanding the world from a different perspective, where the canvas is a sensor's view of the Earth, and the palette is the electromagnetic spectrum. Let's dive into the fundamental principles of image interpretation. The first principle is the concept of electromagnetic radiation. This is the energy that sensors on remote sensing platforms detect to form images. This energy, which we often refer to as light, is part of a much larger spectrum, the electromagnetic spectrum. This spectrum ranges from very short wavelength energy, like gamma rays, to long wavelength energy, like radio waves. Visible light, the portion our eyes can detect, is just a small fraction of this spectrum. The second principle is the interaction of energy with surface materials. When electromagnetic radiation strikes an object, several things can happen. The energy can be absorbed, it can be reflected, or it can be transmitted through the object. The amount of energy that is absorbed, reflected, or transmitted is specific to the type of material and the wavelength of the energy. For instance, water absorbs most visible light, which is why it appears dark in images, while snow reflects most visible light, appearing bright. The third principle is the recording of energy by the sensor. After the electromagnetic radiation interacts with surface materials, the reflected or emitted energy is detected and recorded by sensors on remote sensing platforms. These sensors are sensitive to specific ranges of the electromagnetic spectrum and can record the intensity of the energy they detect. This recorded energy is then used to construct images, allowing us to visualize the Earth's surface in ways that would be impossible with the naked eye. These principles lay the foundation for how we make sense of what the sensors capture. Understanding these principles is key to interpreting images and unlocking the secrets hidden within them. It's truly a fascinating world when we look beyond our eyes, and that's the beauty of image interpretation. Just as there are many colors in a rainbow, image interpretation comes in many types. Now, let's dive into the spectrum of these types and understand their distinct characteristics. First up, we have visual interpretation. This is the most traditional and intuitive form. It involves the use of human eyes and brain to identify patterns, shapes, and colors in an image. However, it's worth noting that the accuracy of visual interpretation is highly reliant on the interpreter's skill and experience. It's a bit like reading an ancient manuscript. The more familiar you are with the language and symbols, the more accurately you can interpret the meaning. Next, we have digital interpretation. In the age of technology, digital interpretation is rapidly gaining traction. It involves the use of computers and algorithms to process and interpret images. The strength of digital interpretation lies in its ability to handle large volumes of data quickly and accurately. It's like having a fleet of tireless scribes at your disposal, each one dedicated to deciphering a part of the manuscript. However, it's not all sunshine and rainbows. Digital interpretation also has its limitations. For example, the algorithms used in digital interpretation can sometimes be too rigid, failing to capture the subtle nuances that a human interpreter might pick up on. So, while digital interpretation is powerful, it should be complemented with a touch of human intuition. Another important type of image interpretation is multispectral interpretation. This involves analyzing images captured at different wavelengths of light. It's like looking at the world through a kaleidoscope, each color revealing a different aspect of the landscape. Multispectral interpretation allows us to see beyond what our eyes can perceive, unveiling hidden patterns and details. Lastly, we have thermal and radar interpretations. These types use heat and radio waves, respectively, to interpret images. They offer a unique perspective, enabling us to see through obstacles like clouds and even penetrate beneath the Earth's surface. Knowing which type to use is crucial in extracting the right kind of information from the images. So, as we journey further into the realm of remote sensing and image interpretation, let's remember to appreciate the diversity of tools at our disposal. Image interpretation is not a haphazard process, it follows a series of well-defined steps. So let's delve into these steps, shall we? The first step is data acquisition. This forms the very foundation of image interpretation. Here, data is collected from various sources such as satellites, aircraft or drones. This data is then converted into images. It's like gathering the raw materials you need to build something. Next comes pre-processing, the second step. Think of it as refining the acquired data. Here, the images are corrected for distortions and noise that might have occurred during data collection. This step is crucial to ensure that the images are accurate and reliable. It's like smoothing out the raw materials before you start building. The third step is image enhancement. Now this is where things get interesting. Image enhancement techniques are applied to improve the visibility of features in the image. It's like adding a coat of paint to your building to make it more appealing. Now we move on to the fourth step, classification. Here, the enhanced images are categorized into different classes based on the characteristics of the features present. It's like labeling the rooms in your building so that you know what each one is for. The final step is validation. This is where all the previous steps are checked and double-checked to ensure that the interpretation of the image is accurate and reliable. It's like conducting a final inspection of your building to make sure everything is as it should be. Following these steps ensures accuracy and reliability in the interpretation process. It's a journey, really, from gathering raw data to refining it, enhancing it, classifying it, and finally validating it. And though it might seem complex, remember, every journey begins with a single step. So why not take that first step and dive into the fascinating world of image interpretation? After all, who knows what you might discover? In image interpretation, it's essential to understand its elements. It's kind of like understanding the ingredients that make up a gourmet dish. Let's break it down. First, we have tone. This refers to the relative brightness or color in an image. Different tones represent various features like water bodies, forests, or urban areas. A change in tone can indicate a change in the features. Next up, shape. This refers to the general outline of objects. Regular shapes like squares or circles might indicate human-made features, while irregular shapes are often natural. Size is pretty self-explanatory. It's the dimension of the object or feature within the image. This can help us differentiate between, say, a pond and a lake, or a house and a shopping mall. Pattern is the spatial arrangement of visibly discernible objects. An orderly repetition might suggest a human-made feature, like a row of houses. Texture refers to the frequency of tonal change in an image. A smooth texture might indicate a calm lake, while a rough texture could suggest a rugged mountain range. Shadow can provide an idea of the profile and relative height of certain features. It can also help to identify the time and direction of illumination. Last but not least, association. This is about the relationship between different features. For example, a school might be associated with playgrounds or sports fields. These elements are the building blocks that help us derive meaningful information from the images. As we navigate the cosmos from our screens, it's essential to understand how we make sense of what we see. We've journeyed together through the captivating world of remote sensing and image interpretation. We've delved into its principles, which underpin our ability to turn pixels into meaningful information. We've explored the various types of interpretation, each offering a unique perspective on the data we collect. Next, we embarked on the steps of image interpretation. From data acquisition to information extraction, each step is crucial in shaping our understanding of the world. Lastly, we touched on the elements of image interpretation, the irreplaceable building blocks that form the foundation of this fascinating field. So next time you see a satellite image, remember the intricate process that goes into interpreting it. Reflect on the principles, types, steps, and elements that we've discussed today. Until then, keep exploring, keep learning, keep subscribing to Quest. Thank you. Let's now cast our eyes towards the horizon, where the field of image interpretation is poised for incredible advancements. As we step into the future, The integration of artificial intelligence and machine learning is set to revolutionize the way we interpret images. Advanced algorithms will be able to sift through vast amounts of data, identifying patterns and extracting information much faster than any human could. This will not only speed up the process but also open up new avenues for discovery. Imagine the possibilities with real-time image interpretation. A world where we can monitor environmental changes, track natural disasters, or even observe wildlife in their natural habitats as they happen. This could transform the way we respond to crises, manage resources, and understand our planet. And let's not forget about the technological leaps in our satellites. With every new generation, the quality of images we capture improves dramatically. This means more detailed, higher resolution images that offer us a clearer, more precise view of our world. So, as we venture forth, remember that the future of image interpretation is bright, filled with endless possibilities. Stay curious, stay excited, and keep exploring the world from above. Until our next journey, this is Quest signing off.